So let's go for the second part of the workflow using bridge feature inside InfraWorks. So here I will create a new design proposal. So I can keep the master like it is with the pre-design based on decoration. So here the decoration. So I will remove this road assembly by a more, I would say, classic road assembly where there is nothing inside. Yeah, call it null here. And I go from the beginning to the end. Let's finish. Yes. So I have my line, road, and of course the Revit file for the beginning of the gondola lift. So on this road, I will add the bridge from the beginning up to the end. And of course, I will use a specific gondola template. But at first, I won't, so you can see what has changed. So here it's a classic template, Ashto. And I will move for my template here, so you look. So of course, we have done the same. So the Revit file or inventor file for the pylon and the gondola and the cable. And here you can change the spacing of the pylon and gondola, like you have. The difference is you can change here one by one, because the other you can change all around. Here you can move only one pylon or one element. So here I will look for the longitudinal profile. So I just right click on the road and show a station in profile view. So here after I display all, it's already dropped, and I will adjust my profile. So here you have point, and you can change every point, and you can remove and add new. So if you want to see where you are, you can activate the tracking, so you can see in kind of yellow here. So here I will stop the tracking so I can pick a point. So here, and so I will adjust the element. Here, since usually it's not a cable, it's a road, here you have geometry adjustment, so symmetric or not. Here you don't need because it's a cable. So I remove it like this. I will do the first at the end of the gondola lift to come without any loop like this. And then I validate. Of course, the pylon and all the elements you have imported from Revit or Inventor are parametric, so it's exposed there. So you can change it. And if you want to change, you can upgrade the Inventor or Revit file. Here it's an Inventor, so you click and you can open it. And of course, you have all the parameters exposed. You can change them, upgrade them, and load them again if needed, or create a new style if you want. So let's change the parameter. For example, the angle, the size of the slab, like this, and the thickness of the tube. And of course, here, the difference is one by one. You can change manually or typing a value for every column and change the parameter of the pylon. So you can type the value, but as engineer, you like Excel. So of course, all of this can be changed through a big Excel file. So you just have to create it. Then all what is in blue, you can modify, set the new value, save, and after you make the Excel upload again. So here you have for every element, of course, here we don't have deck, of course, but foundation, pier, and 3D grider as cable if you need. So here I will change the pier 11. Like you can see, I will save and I will update it again. So if I come back here, I can update from existing, and as you can see, it moves directly. So it's really powerful, even for the classic bridge, I would say. But here, and after, sometimes to adjust, it's nice to see the level where we are. So here we'll display it. So around 2000 meters, like you can see, and you have the level, and you can have different minor and major interval, like you can see. It can help you to define your project and to define new slope to go from one lift to another if needed. In the next video, you will see how to export to AutoCAD Civil3D to create shop drawing.